right, so today, welcome to Mr. Graves' Anatomy Lab / Garage for another dissection. What I have for you today is a sheep heart that I'm going to show you the parts of. I also have a cow heart here, so you can kind of see comparatively the size of the heart between the two animals. The cow heart on my left and the sheep heart here. We're going to actually look inside of the sheep heart because this is the dissection we would have done in class, and I thought this would be a fun kind of last day of school thing for you guys to see. If you can come on a little closer with the camera now, we'll look at some of the external anatomy of the heart first. First of all, I had to remove this covering that was around the heart. You can see I kind of cut it around the top and around the bottom. This covering is the pericardium that helps to protect the heart and lubricate the heart so it doesn't dry out. And as we look at the front of the heart here, we can tell it's the front because we see these vessels coming down diagonally. We're going to have your coronary arteries coming down the front of the heart. Those coronary arteries and veins, we can't really distinguish between them here because they're not injected with latex dye, are what provides the heart muscle itself with oxygen so that the heart doesn't die. If you get a blockage or a real bad narrowing in one of these, you can have a heart attack because that cuts off oxygen to the muscle of the heart itself. And so if you are lucky to catch it in time, you might have to go in for a bypass surgery where the cardiothoracic surgeon would take a blood vessel either from your chest, you would take an artery from your chest or a vein from your leg, and they would attach it below wherever, if the blockage was up here, they would attach that blood vessel down below that blockage and then connect it to another blood vessel like the pulmonary, like the aorta or the pulmonary vein, some other blood vessel, so that you would get blood flow to the parts of the heart that would not have received blood flow because of that blockage. So this is one of the coronary arteries here. Another way you can tell this is the front is this blood vessel here that comes off from the right side. This comes up from the right side of the heart. This is the pulmonary trunk. The pulmonary trunk is going to be responsible for pumping deoxygenated blood into the pulmonary arteries, the left and right pulmonary arteries, to travel to the lungs to pick up oxygen and then come back to the heart through the pulmonary veins. The pulmonary trunk and pulmonary arteries are the only arteries that carry deoxygenated blood. Let's see here, some other blood vessels. Let's see if we can see them here. And this one here, if I follow this one down, it's going to take me into the inside of the heart, into the left side of the heart. So this is going to be the aorta. This is that big, largest blood vessel in the body, carrying oxygenated blood away from the left side of the heart, and it will carry that oxygenated blood through the whole body, through the systemic circuit, from your brain all the way down to your toes. So that's kind of the outside of the heart. We have this little flap here. This is called the auricle. It's connected to the atria. There's one on each side, although I kind of removed the one on the left side was removed with the pericardium when I cut the pericardium out. All right, so going back to the heart, we'll open it up here. I cut this ahead of time. So what we see here, this is all the myocardium, right? This is where the cardiac muscle is located. The epicardium is the thin outer covering that wraps around the heart. And then the smooth lining of the chambers of the heart, that's the endocardium. We have this wall that separates the left from the right side of the heart. And if I take a look, this would sit in my body like this right here. So this top part of the heart, if you remember, is called the base. The bottom is called the apex. And the apex points towards the left ilium, the left hip bone. So when I open this up, this is going to be the left side of the heart. This is the right side of the heart as it sits in the body, anatomical left and right. So when I look here, this is the interventricular septum that separates the left side of the heart from the right side of the heart. And we notice that the wall of the left side of the heart is much thicker than the wall of the right side of the heart. The left side of the heart has to pump blood much farther around the body, like I said, from the brain all the way to the toes. So this muscle is much bigger because it pumps much harder, whereas the right side of the heart only pumps blood to the lungs, which are sitting right next to the heart, so it doesn't have to work nearly as hard, so the muscular wall is not as thick. Up here, this area here is going to be our left atrium. We don't really see the right atrium much, maybe a little bit of it here on this section, but here's the left atrium. This flap right here is the valve that separates the left atrium from the left ventricle. If you remember, that valve is the bicuspid or mitral valve. It has attached to it these stringy-like little structures. These are the chordae tendineae that are attached to bumps of muscle in the bottom of the heart that are called papillary muscle. And the function of these is to prevent this valve from prolapsing, which means opening up backwards up into the atrium. So when the left ventricle squeezes, blood is forced up, and it would be forced up against this valve, and without these chordae tendineae, that valve would open up back into the left atrium. So this valve prevents the backflow of blood from the ventricle back into the atria. And over here on the right side of the heart, you can see a little bit of the tricuspid valve here that separates the right atrium from the right ventricle. The interventricular septum separates the right ventricle from the left ventricle, like we said. That prevents the deoxygenated blood in the right side of the heart from mixing with the oxygenated blood in the left side of the heart. Let's see if there's any other structures that I wanted to point out here to you. I think that is pretty much it. So hopefully you enjoyed that dissection of the heart here in Mr. Graves' anatomy lab. A lot of you said that was one of your favorite units when I gave you your survey, so I thought I would show you the dissection we would have done had we been in class. So stay safe, stay healthy, enjoy your summer, and hopefully I'll get a chance to see you guys again in the fall sometime if you come back to visit, or if you're a junior and we're back in school. Have a good day, everybody.